In Blender, we have 3 different rotation methods. By default, when you're creating an object inside Blender, it will default to Euler. There is 6 different Eulers, and we'll get back to them in a moment. And we have quaternions and axis angle. When you're creating an armature and enter pose mode, the bones will default when they're created to quaternions. Now you can change that with the little drop down here. Right? So let's first take a look at axis angle and what it does. Now, axis angle is a rotation method where X, Y, and Z defines a point that is relative to the object's pivot or origin. Now, this point and the origin then define an axis for the W, which is defining the rotation. So basically right now, if I take the W, which is in degrees, and X, Y, Z are in basically floating values, if I spin this, it spins in the y-axis because the y is at 1, x is at 0, and z is at 0. So it's perfect for spinning in unidirectional. Now, it's also perfect if you need weird angles. So if I set these to 0.5 each, I will get a perfect rotation going from this corner to this corner, so in 45 degrees in 3D space. Now, if I would set them to minus 0.5 and minus 0.5, and keep the other one at 5, you'd get the other axis. All right. So it is very useful if you need a spinning action in a weird angle that is not directly the world or the object X, Y, and Z. All right. So it's a little bit confusing, but I can see totally the different use for this. So it is really great for weird angle that are spinning in a single axis. All right, it's a little bit hard to understand visually. You have to fiddle a little bit to understand how to set your axis with this type of arrangement. And it's a little bit hard to understand if you actually key those and key that one inside the graph editor, because it's not like the usual Euler angle. Especially useful for rigid body dynamics. So if you want to know a little bit more about this, just take a look at the link below. All right, so now let's take a look at the Euler angles. Now, Euler rotations are applied to each of the X, Y, and Z in a very specific order. So it's a parent-child relationship in this case, all right? Now, it's perfect for single axis spinning action and motion. It's also usable for simple double axis actions like a simple arc with a camera and stuff like that. However, when you use 2 or more axes, you can get what we call gimbal lock. Now, to demonstrate a gimbal lock, simply go to the transform orientation and set it to gimbal and put the rotation gizmo on. All right. So in Blender, when you read the Euler, so for example, here you have X, Y, Z, you have X, Z, Y, X, Y, X, Z, and so on and so forth. So the way to read it is to read it backward. So the parent, the absolute parent is the last one, so it's Z. So this read as X is the child of Y, which is the child of Z. So to demonstrate, all right, if I rotate the Y axis, you will notice that X follows. Now, if I bring it to a point where it meets the actual Z, you get 2 axes that are spinning on the same axis. All right. So you've got, in this case, Z and X that cross. So the 2 intermediate one. All right. So I'm just going to clear the rotation. So in this case, X and Z will cross. So if I switch this to X, Z, Y, in this case, it's going to be X and Y that will actually cross at some point, right? And so on and so forth. So if you want to use Euler, just make sure that you use the right one for the motion that is needed. Now, if you're using it on an armature level, make sure that it's on a bone that is not gonna use all 3 axes at the same time with very extreme angles, all right? And from there, set the appropriate one for the type of motion that that bone has to do, all right? So that's that. Otherwise, use quaternions. So quaternions have advantages over Euler, which Euler also have advantages over the actual quaternions. And the advantages of the Euler is that it's great for single axis spinning action and rotation. It's also good for double axis rotation with proper Euler setup, as we just seen. They are also very easy to understand mathematically and in the graph editor. So if you imagine each of these axes or one of these axes being a line from 0 to an infinite number in the positive as well as in the negative, it's very easy to understand. Now, where they lack is how they're parented from one another, and to a certain extent, they will get to a point where they will actually create what we call a gimbal lock by meeting two of these axes on the same level. Now, that's one of the disadvantage, and also another disadvantage that it has is when you're using many keys for a more of a 2D style animation where you key in your slow ins and your slow out as opposed to actually relying on the interpolation curve, so the F curves, then you'll get a poor actual interpolation. So Euler's is best if you're going to edit your graph editor, all right? So this is where quaternions actually excel. So you can switch an object to quaternions as well. Now, quaternions are defined by 4 values, so x, y, z, and w. Now, x, y, z do define an axis and w an angle, pretty much like the axis angle type, but it's not quite the same thing. Now, quaternions can be interpreted geometrically as a point on a unit sphere in 4-dimensional space. Now, here's a great example without explaining it because the math behind it is just simply mind-boggling, right? Now, quaternions uses float numbers ranging from -1 or lower to 1 or higher. And when keyed, the interpolation will always take the shortest path, which makes it ideal for 2D style animation where you're keying your own slow ins and slow out and relying less on the F curves as you're working. Right, here's a very simple example that illustrates the difference between the arbitrary interpolation of keyframes of all 3 axes or more of the quaternions versus the Euler. So the quaternion is the purple one and the yellow arrow is the Euler. So if I select it, you'll see that there's 2 keyframes, one on frame 1, one on frame 100. Same thing for the quaternion. And what I've done is I tried to align the arrow as best as I could, just using the gizmo rotation like this on one point. And then I went to frame 100 and I did that for that other point, and I did the same thing for the Euler with all axes keyed, and this is the interpolation that it naturally gave me from it. So the quaternion goes from a straight line, so takes the shortest path, and the Euler is straying a little bit off the path, so you'd have to edit the F curve to get a similar result. So it just goes to prove that the quaternion are a little bit better at interpolating between arbitrary keyframes of all axes. So really not ideal for spinning action, but the advantages is that you do have better interpolation on arbitrary multiple axis rotation. You do not have the suffering of the gimbal. You'll never be able to gimbal cross a quaternion, pretty much as well as a axis angle. You cannot gimbal cross an axis angle because it's not computed the same way as in Euler. Only Euler suffer from gimbal locks. So quaternions themselves are often used in character animation because they allow to animate all 3 angles quite easily without having any issues for specific joint like the actual shoulder joints or the hip joint where the thigh is meeting the joint. Well, you have a greater range of motion there, so you need a bone that is able to do it without gimbal locking, and this is usually where quaternions actually excel. Now, they're also great for relying more on keyframes than on F-curves. So if you don't like to work in the graph editor, you will prefer quaternions over Euler. Now, if you're somebody that likes to edit the F-curves in the graph editor, now you'll probably won't like quaternions as much because the F-curves are harder to understand in the graph editor, and also probably because the math behind it is very mind-boggling and quite hard to understand. Now, if you wish to know more about quaternions and how they actually work mathematically, you can visit the following link that is displayed on screen for a very in-depth explanation on how it actually works, and some of the snippets from earlier were actually taken from that page just to represent how the quaternions actually work visually. So there's no right or wrong. Use what works for the situation that you need. A lot in rigging is really about problem solving skills, and sometimes certain things will not work, so you have a bunch of options that you can actually choose from, and that goes true for constraint, that goes true for actual drivers, and also for the rotation types that you need to use for the given animation that is going to be required by whatever project that you're actually taking on.